Now, this one says to solve using the addition method. I also refer to it as elimination. So when you're doing the addition/elimination method, you pick which variable you want to eliminate. So I'm going to choose y. That's what I want to eliminate. You could have chosen x, and that's okay. So look at my two equations. So I got 3x plus 2y equals 48. And 9x minus 8y is a negative 24. Okay, looking at my y's right here. I want to ask myself, what does 2 and 8 both go into? Well, they both go into 8. So to make this an 8, I have to top the top equation times 4. I already have an 8 on the second one, so I take it times 1. Look at the signs in front of my y's. Do I have the opposite sign? One's positive, one's negative. So I do have the opposite sign. If the signs are the same, make one of your numbers a negative. It does not matter which one. Okay? So when I multiply, I get 12x plus 8y equals 192, and 9x minus 8y equals a negative 24. When I add those equations, look at what happens to those y's. So adding 21x equals 168. Divide both sides by 21 to find x, and x equals 8. Are you with me? Okay. Now that I know x, so I know my answer is going to be 8 and then something. I don't have an equation solved for y like I did on substitution. So I pick one of my two equations. I'm going to pick this one, and I plug my x in. So 3 times 8 plus 2y equals 48. And I'm going to solve for y. So multiply, subtract my 24 from both sides, and divide both sides by 2. So your answer is the ordered pair 8, 12. All right, moving on, guys. Okay, now on this one, if you look at the two equations, they're not set up the same. When you're solving by the addition method, it has to be set up to where you have your x and then your y and equals your constant. So on this equation, I'm going to subtract 7y from both sides. So I have 2x minus 7y equals a negative 48. On the second equation, I need to add 3x to both sides. 3x plus 5y equals 17. So here's my two equations. This time I'm going to choose to eliminate x, just to change it up and show you that it makes no difference, okay? So you ask yourselves, what does 2 and 3 both go into? They both go into 6. So if I want a 6 in front of the x on top, I take it times the 3. If I want a 6 on the second equation, I have to take it times a 2. Now, if I look at my x's, they both have positive. So one of those numbers, I have to make a negative. I chose the 3. It does not matter which one you make a negative, okay? So multiplying, now I have negative 6x plus 21y equals 120, 144, I believe. So let me double check that. Yes. And multiplying by 2, 6x plus 10y equals 34. Again, when I add, you notice this time the x's cancel. So I have 31y equals 178. Divide both sides by 31. And it does not reduce. So let me make sure I didn't make any mistakes up here. Okay, 2x minus 7y, 3x plus 5y, times the negative 3, and negative, positive, positive, times 2, 178, 21, and 10. Okay, so we have that y is 178 over 31, and it does not reduce. Okay? So now I'm going to say 2x, plugging back into this equation here, equals 7 times my y minus 48. Punching that in the calculator, 7 times 178 over 31 minus the 48, I get 2x equals 242, a negative over 31. Divide both sides by 2, and I get negative 121 over 31. I believe, and don't quote me on this, that I tried in my math lab not to give you any fractions, okay?